Hello and good evening. Today we have given an assignment to do a piping system layout, to design a piping system layout, which include a pump, cooling condenser and cooling tower for process cooling application. So for this assignment, we need to choose the best selection for pipe sizing and specify the pump required. And the question is, if the capacity of water is 5 meter cube per minute, the pressure drop in the condenser is 6 meter of water gauge. The vertical distance between the pump center line to the top of the cooling tower is 20 meter. The horizontal distance from the condenser to the tower is 21 meter and the centrifugal pump is 5 meter below the tower basin. All the necessary accessories are shown in figure 1. The velocity in the pipe has to remain 3 meter per second and below to avoid noise and erosion inside pipeline. So this is the piping system for cooling process. Write the value that have given in the question. So for the capacity water or the flow rate, 5 meter cube per minute or 0.08333 meter cube per second. And for the pressure drop is 6 meter from the water gauge and the velocity is 3 meter per second. So we need to remain the velocity 3 meter per second or below 3 meter per second. So for the first solving, we need to find the diameter of pipe, which is the formula square root of 4 times V flow rate divided by pi times with velocity. So we do the calculation and find the diameter of the pipe sizing. For next calculation, we need to find Reynolds number to put it into the formula. So for the Reynolds number, the formula is rho VD divided by dynamic viscosity, or V times with D divided by kinematic viscosity. So for the temperature and the dynamic viscosity, we can find it at the internet. So we do a calculation, then we can find the Reynolds number. So if the Reynolds number is greater than 4,000, that is condition for the turbulent. If the Reynolds number below than 2,300 is the laminar condition, and if the Reynolds number is between 2,300 and 4,000, that is transition flow. Okay. Next calculation, we need to calculate head loss total equal head loss minor plus head loss major. Head loss minor due to component as valve, bends, teeth and the like in the pipe or duct system, and for the head loss major due to friction in pipes and ducts. So for this piping system, we have 4 valve, open gate valve, and 5 90-degree elbow, and 2 expansion joint, which is expansion and contraction. And for the condenser, we have exit and entrance inlet. So for the first calculation, head loss minor, we need to find elbow 90-degree head loss. We using this formula K times with V square divided by 2G. K is referred as loss coefficient, V is referred as velocity, and G is referred to gravity. So we calculate and we find the elbow 90 degree. So for this calculation, after we calculate the head loss, we need to times with 5 elbow 90 degree, which refer to the 5 elbow at the question. And for the head loss gate valve, we are using same formula and find the head loss at the gate valve. And for this also, we need to time with 3 valve, because from the question we have 3 valve, which is open gate valve. Next, we need to calculate head loss for expansion and contraction. Difference between both of this condition Expansion is referred to the smaller diameter to the bigger diameter, and contraction is referred to the bigger diameter to the lower diameter. And lastly, we need to calculate head loss for the condenser. Head loss condenser have a exit inlet and entrance inlet for the condenser. So we need to calculate the head loss for the both exit and entrance for the condenser. Okay, before we start to calculate for the head loss measure, we need to find the friction factor, which is F first. Friction factor is equal to 100 times with Reynolds number, power of -1/4. This formula is referred to the turbulent condition. For the laminar condition, for the friction factor, we use formula 64/RA. Then after we find the friction factor, which is F, we need to put it into the formula, which is F equals F times with LV square divided by 2 times with D and G. L is referred to the length, V is equal to the velocity, D is equal to diameter, and G is gravity. So we can find the head loss measure. After we calculate the head loss minor and head loss measure, now we can calculate the head loss total. For the information, we need to add the pressure drop at the condenser, and we can get the head loss total. Then for the head pump is equal to the Z2 minus with Z1 plus with head loss total that we get it from this formula.